on Azure SQL database business continuity. So thank you, Harry, for inviting me to speak tonight. For those of you that I have not met yet, my name is Jes Schultz. My pronouns are she and her. I'm a product manager at Microsoft, so I help build Azure SQL database. I currently live in Louisville, Kentucky. Been here just about 2 years now. Yes, I love bourbon, and also I did before I moved here. When I am not working with databases, I also love running and eating, which might be closely related, and you can see some of my little zoo off there in the pictures. I love connecting with people that have watched my presentation, seen me at conferences, etc. So you can find me on Twitter. I'm there pretty much every day. Connect with me on LinkedIn. Also, check out my GitHub repo. I have some projects out there, and also that's where I put my updated presentation slides. So if you want to go grab these slides to review at a later time, that'd be the best place to go get them. So what are we going to be talking about tonight? Business continuity. And why? Well, data is, in today's world, the single most important asset for companies. So for most companies, right, the data is the business. If companies are losing access to their data or they lose the data itself, they're going to be losing business, they're going to be losing money. That's a threat that anyone that works at a business can understand. And so as data administrators, data stewards, right, one way that we mitigate this is through a business continuity plan. And to define business continuity as this really broad term, I found a great definition online, which says it's a process-driven approach to maintaining operations in the event of an unplanned disruption. I love a couple things out of this definition. First, that it's process-driven. This isn't something that just happens by chance. It's not something that just appears one day. It's a set of steps that are built and taken and tested that get you there. The other thing is the event of an unplanned disruption. When we think about business continuity, we might hear about things like high availability and disaster recovery, which we'll talk more about on the next slide. And you might automatically go to things like power outages, natural disasters, but unplanned disruptions can span just a much larger swath of events than that. An unplanned disruption could be someone running a delete statement without a where clause, or an update statement without a where clause. Raise your hand if you've done that before. I'm guilty of it. An unplanned disruption, particularly if you're in the cloud, could be that the SQL database service itself is up, but maybe the networking to your region is down, or a storage account that you rely on is affected. So there's a lot of different unplanned events that could happen, and you need kind of a solid strategy around your databases to accommodate for a variety of different things. So what we're going to talk about tonight, we're going to talk about the foundation of any business continuity plans, which are backups. So a transactionally consistent record of the database at specific points in time. We're going to talk about restores, where we take the backup and recreate the database as of a point in time. I'll also talk about high availability, which in this case really means recovering data within, if you were on-prem, I would say the same data center. If you're on the cloud, I would say the same region, versus disaster recovery, where you're going to be putting your data into a secondary data center or another region. And these secondary data centers, if you're on-prem, you could have two that are 10 miles apart, right? That might be enough of a risk differentiator for you and, well, your company and its insurance company. If you're on-prem, you might have one on-prem and one in the cloud. If you're in a cloud, you might have different regions, you might even be cross-cloud. So this spans a lot of different things. There's a ton of options out there these days. So now when we think about in the on-prem SQL Server world, a lot of this falls onto the DBAs, data administrators. So I started my professional career as a DBA at Kimberly-Clark back in 2010. It's been a while, but some of the things we had scripts to set up backup jobs on every single SQL server, whether it was development or production. The frequency of backups might change, but everything was backed up. You should have some sort of method in place. Remember that process-driven approach to, on a regular basis, take a set of those backup files, restore them to a different server or different environment to make sure those backups work, your processes work, how long those restores take. For high availability with SQL Server, we might set up something like Windows Server failover clustering and then build a failover cluster instance or an always-on availability group on it. For disaster recovery, again, might set up like a distributed availability group or an asynchronous availability group. Might even use, to this day, one of my favorite technologies, log shipping. So lots of different options there. But here's the thing, that becomes a lot of work, especially if you have dozens or even hundreds of SQL Server instances and then hundreds or thousands of databases, right? That's a lot of backup jobs to build out, a lot of restores to test, a lot of HA plans to think about. So one of the nice things about moving to the cloud, particularly Azure, is Azure makes this easier, right? So Azure SQL Database is going to do a lot of this heavy lifting and I will say the tedious work for the DBA. And that's what we're here to talk about tonight. How does Azure SQL Database in particular help with those backups, restores, high availability, and disaster recovery? How can it make your life as a DBA easier? So let's start with our basic foundation, which are backups. So every single Azure SQL database, whether it's a single database or part of an elastic pool, whether it's general purpose or business critical or DTU based, whether it's in a managed instance, is always going to have backups taken regularly. So the default schedule is a full backup every week, differential backup every 12 or 24 hours, and then transaction log backups that are taken at least every 10 minutes, maybe more often, just depending on the volume of transactions in the database. With the exception that the hyperscale, like distributed architecture, uses storage snapshots, but hyperscale is its own presentation sometimes. So we automatically take the backups for you. In addition to that, the backups are also redundant. So they're geo-redundant, which means there's a copy of the backup in the same region as the database. And that backup is also replicated to a paired region. So when it comes to disaster recovery, we'll talk about how we can use those backups. So a couple of things to note: the backup files are compressed, right? So they're going to be taking up less space in storage than they are when they're fresh. And then how long are they stored is another common question I get. So the default is between 7 and 35 days, kind of just depending on what tier of service you choose. If you need longer backup storage, you can enable long-term retention, which you might see a couple times as LTR. LTR setup puts like full backups off on Azure storage on a schedule you choose, and then can be accessed for a much longer period in time.
Hey, Jess, I have a question, if you don't mind answering.
Go for it.
So when you mentioned all of this stuff goes to Azure Blob Storage, ultimately it's somewhere in the cloud, and you said that the files or the data is replicated between regions. Is there an added cost for the replication of data to a secondary region, or can you say I only want it in one region if the cost is high?
For your backups, there is no additional cost for replicating the data to that secondary region. That comes built in.
And there's no cost for storing it in the blob storage, correct?
No, correct. So so the fine points of Azure pricing. When you are paying for an Azure SQL database, you pay for X amount of storage. Say, I'm just going to pull a number here. Say you have 500 gig of storage. Say that your database, so your data files can take up to 500 gig of storage. The pricing for that Azure SQL database includes an equal amount of storage for your backups. So you can have up to 500 gigs of backups at no additional charge. That's why I mentioned the compression piece, right? Like on average, I think it says 3 to 4x compression. If you were to exceed that equal amount of backups in your short-term storage, then it would be billed as extra. I don't know if that happens a lot. But then again, the same thing would apply to the best of my knowledge, again, the geo-redundant backups, as long as it's within the total size of the backups within the same size as the database, that pricing is included.
Thank you.
Does that clear it up a little bit?
It provides further things to think about, but yes,
Okay.
thank you.
Okay, excellent. So how do you set this up? I'm going to show some screenshots of the Azure portal because that's an easy way you can view things exactly the same way. When you're looking at your database, right, you can go to this compute and storage button. Oh, let me turn on my fancy little pointer. I miss presenting in person and using my pointer, although I forgot it half the time anyway. So you have your compute and storage screen or blade. And one of the things you'll see is backup storage redundancy, geo-redundant backup storage. And again, that's the default. If you don't need that, you could set it, or for data residency requirements, you can't have it replicated to a secondary location. You could say either zone redundant or locally redundant backup storage. So that's backups in a very small nutshell. Any further questions about that?
Sorry, you mentioned zone redundant and local. So does that mean that if in a particular region, you could have it only in one of the data centers versus multiple data centers, or?
Essentially, yes.
Okay.
And I have a slide on availability zones and what that means in the HA section, which would also apply here. But yes, locally redundant backup storage means the data would exist, the backups would exist on more than one set of storage within the same data center.
Okay.
Zone redundant means it would be on at least 2 sets of storage within the same Azure region or location, but at different data centers within that region. And then geo-redundant is completely different region. Yes.
Okay, thank you.
You're welcome. So lots of options there. And again, the zone redundancy comes into play. So we have these concepts of Azure paired regions, right? And I don't remember them off the top of my head, but say East US paired with Central US. Across the world, it might be something like, West Europe paired with Eastern Europe. There are certain countries, states, municipalities where there are data residency requirements, right? If the data is created in a specific location, it must be stored there. We don't have a data center in every single country, every single state. Thus, you can still meet your requirements, but yet have another level of security of your data by using something like zone redundancy. All right, so lots to cover yet. I'm going to move on because I could talk about backups alone for an hour, but there's a lot more going on here. All right, so let's talk about then restores, right? So say something happens to your data and you need to get a copy of it back. One of your Easiest things to do is restoring the database. One of the benefits of restoring your database in Azure versus, say, on premises is because this is all kind of done in the background as a DBA or as a developer. If I was on-prem, I would have to go, okay, I need to restore my database to Monday, 6:42 p.m. I need to figure out which full backup, which differential backup, and which log backups need to be applied, run a script, restore all of that, make sure it's set to, with no recovery, put it back in multi-user mode with recovery. In Azure, all of that's taken care of for you. You don't have to worry about which backups need to be restored in which order, or putting anything back in, changing recovery models or user modes. What you do is you simply either go to the portal or use PowerShell or CLI. You specify the name of the database and the day and time you want to restore to, and all of that is taken care of for you. And it really is that easy. There's a few different restore scenarios that are available. So I want to drill into these a little bit more. And I apologize that yellow may not be super readable. I tried to change the color a couple times. So first, maybe you just want to restore. So you have an existing database on a logical server in Azure. You want to restore that database to a point in time. So the default is going to be restoring. It makes a new database on the same server with a slightly different name. And that's one of my demos. I'll show that to you. So that's an easy thing when you have kind of those oops scenarios, right? Someone deletes a table, deletes all the data in a table, changes some data that they shouldn't have. In this case, just like doing it on-prem, you could either try to transfer the data between the two databases or simply rename the old one and make the new one, the restored database, the original database name. So a couple different things you could work around there. If you've deleted a database and you want to restore it, first off, it has to be within that window of available backups that you have. So again, standard would be somewhere between 7 to 35 days, or you can use something from long-term retention if you've enabled it, and then you can restore it to the same server. If you have configured that geo-redundant storage and you do need to restore your database to that secondary region, you would have to have, again, a separate SQL server in that secondary region, and then you could restore the database there. And then your last option is, again, if you have long-term retention enabled, you can go into a server, pick your databases there, pick your long-term backup, and restore that specific file.
So I have another question. My apologies.
Yes.
Can you restore a database to a new server, same name? Meaning that I just want to put it on another, basically take that point in time backup, put it on a new server and a new same name. Is that possible?
So no, that capability does not exist at this point in time. So there's no way to say in a specific region, like in East US, I have SQL Server 1, 2, 3, and I have SQL Server 4, 5, 6. If the databases and the servers and the backups still exist, you have to restore it to the same server. In order to move it to a different server, you'd have to use something like import-export service, or set up a geo-redundant copy. Not a geo-redundant copy, a failover copy of it.
Okay, because the third option is geo-redundant, but it does the server
Correct.
to, yeah. It's interesting that Microsoft doesn't offer that, but I understand you can't get everything you want.
Yeah, I don't know all of the technical or financial or whatever reasons behind it. And that third option, again, exists only in that paired region. Like if East US and Central US are paired, I have my backup in East US and my backup pair in Central US. If East US is out of commission, I can't go to West US and pull that backup and restore it there. I have to do it in Central US. So there are limitations around that as well.
So I don't know if you're going to get into this, but as far as like logging and alerting for a customer if a backup fails, if you can go into that, if you can.
I was not going to go to that level. This is a little bit higher level of a talk on just the overall options. I know.
Okay, I'll contact you directly, Jess, for all the,
Okay.
extra money on the side for those kind of
Okay.
answers.
Yeah. Absolutely. If there are additional, like if this sparks some other ideas, I'll try to answer some at the end if we have some time. And if not, you're absolutely welcome to reach out via Twitter or via LinkedIn or via email. Absolutely. I know it's, I know the joy of giving a presentation and not being able to answer all the questions in 1 hour. Okay, so here I am on, I'll go back to where I started, the Azure portal. So what I'm going to do is go into a SQL server. So I have a SQL server, and this is where I can find, first off, a list of all my databases. You'll see I have an elastic pool. I have a serverless database. I have a standard general purpose database. I have a DTU database. Say that I want to say that something happened to my demo 3 database and I need to restore to yesterday and point in time. So what that looks like is coming to this. Oh, yep. All right. Under data management, you have this backups tab here. So you'd come to backups and you're going to see all of your different available backups. So you can, again, there's toggles here for your active databases versus your deleted databases. So with my demo database, you'll note I can either choose restore, or for this one, I actually have long-term retention configured as well. So if I needed, for some reason, to pull a copy out from January, I could. But a basic scenario is going to look like clicking on this restore button and getting some, this is essentially taking you through the same create SQL database form that you would see on the portal at any point in time, with some of the things like what resource group, the source database, and the database name kind of given. So again, it tells you what your earliest point in time restore is set to. So on this one, June 1st, I have 14 days of retention set up. So what I need to do is just go to yesterday. I can say 6:42 p.m. And this is in UTC. It says right there when you're using the portal, it's always UTC. And then it adjusts my database name to show the date and time that I'm restoring to. And I can choose things like what level do I want when this one's created? Do I also want geo-redundant backup storage? One note that I will make here about restoring databases and the compute and storage level you choose. This one was a pretty low grade, right? Like 2 CPU, 8 gig of memory. If you have an important need to restore the database faster, a method that you can use is set the target, this new database's cores and memory higher than the source. That will give it more compute during the restore operation. And then when the restore is finished, just remember to go back in and scale that down to its original. But that can help if you need it a little bit faster. Now, I did not have VS Code open ahead of time to show CLI, so we're going to give it a hot minute here for things to load up on my laptop, if they choose to. Here we go, slow but sure. Okay, let's try to remember if this is in my presentations folder or my scripts folder. Oh, restore dash Azure RM SQL database. There's an oldie but a goodie. Bear with me for a moment. Oops. Azure. There we go. Okay, so I am going to show you how to use command line tools to do this. So the Azure CLI, again, let me zoom in now that I've found this. So I'm just using Azure Data, or not Azure Data Studio, VS Code. So basic commands, right? We log into Azure. It's going to open up my browser to do this here. And I'm doing that because I don't know if I've authenticated recently. All right, there we go. Once you've done that, I'm going to make sure I set to my correct account that I am logged into. And what I want to do is pass in some parameters, right? So the database, so the AZ SQL DB restore command is going to take name, so the source database, the resource group that it's in, the server it's attached to, the destination name, which is the, right, like what I want it to be called. So in this case, demo 03 is not 2022 anymore, surprisingly. What edition, so that's general purpose, what family, which is Gen 5 hardware, capacity of CPUs, and then this is what point in time do I want to restore to. So again, I want to restore to June 2023, and we'll say the 13th. And with our parameter set here, we'll go ahead and we will, nope. Make sure we're in the command prompt for CLI, which is really helpful. Maybe.
No, I jinxed you about
Yep.
timing. My fault.
I didn't like test this demo before I did it today. I wasn't like, I should go run all this. I just assumed it all worked. And then Sharir was like, yeah, it'll be fine. You're gonna go live demos.
And you'll blame me for the whole thing, you know that.
Okay. Okay. Last but not least, we'll try this in our PowerShell window because maybe I'm getting my demos mixed up.
I think I know why speakers doesn't want to come and talk at our user group now.
Because I keep talking too much.
No, you
Yeah,
keep
Does this happen
jinxing
often? Okay, well, rather than spending my whole time trying to troubleshoot this, which is no help to anyone, again, CLI command, a PowerShell command is very similar, right? You're going to see an AC. Oh, here we go. Now it's keeping up with me. Like AZ restore dash database. Come on. I'm just gonna let it do its own thing. All right, so that's backups and restores. You'll see my deployment has succeeded back here on the portal. Now, if I go to the restore, you'll see it's the same, another SQL database with that time and date appended, and everything's just taking its own time. Sweet, sweet time tonight. Okay, here, now if I go back to my SQL server that the database was on, you'll notice I have demo 3 and its restored version with the date and time stamp. And here, now that I realized my internet's just slow, especially because I'm sharing, my DB restore is also running. So shortly I will see a third database starting with demo 003 out here. All right, any other questions about backups and restores?
So via the CLI or PowerShell, when you execute the restore, it is going to wait until the restore is completed. Or is it just going to queue it up and then you have to query to see what is going on? I'm in the AWS world where if you send the command, it just puts it in the queue and then you have to check what the current status is.
Yeah, it's the wild, wild west over there. You would never
Okay.
know a
Hey,
status or
hey,
anything.
hey. It ain't my fault I'm in AWS land. Thanks, AWS.
So it's on the portal, right? So portal is always going to show things asynchronously. The portal is not a super up to date, right? Like everything's synchronous kind of tool. If you start off the top of my head, I don't know what, like if you can check a CLI restore or a PowerShell restore with a command, like what progress it's at. My many PowerShell commands filed away in the back of my head somewhere in there tell me that there is a way to check the progress of a restore via PowerShell, but I don't know off the top of my head.
There, if I'm not mistaken, there is a way to, at least the PowerShell doesn't complete until the process is complete in the other side. So instead of pressing enter and then it gives you another prompt, it waited. So that way it kind of tells you like, oh, it's still running. And I mean, if you're running it through VS Code, it's nice because on the bottom it does say it's like, oh, it's executing scripts.
Yeah, so you can see it's still executing here if you're
exactly.
using like CLI or PowerShell.
Yeah.
The other thing I would say is, like, just wondering if you could go into that SQL Server's master database for a tool like Azure Data Studio and run a command to see like databases listed there. But again, great question. I feel like there's a way to do that in PowerShell, and I just don't remember off the top of my head. Shoot me that via email. I will figure it out, and I will add that note to this slide to talk about next time. All right, so let's move on to the next section then, which is talking about high availability. So the benefits of Azure are that your high availability, right, that recoverability within the same region is built in, which means you don't have to choose anything. The downside to high availability in Azure is that based on your service tier, your high availability options are chosen for you, and you don't get to customize anything. So you win some, you lose some, but depending on the service tier you get, you're going to have some solid high availability behind you. So your HA options are entirely tied to which, again, in this compute and storage layer, it's entirely tied to which service tier you're going to be using. So we have in DTU, basic and standard are equivalent to vCore general purpose, DTU premium equivalent to vCore business critical, and then hyperscale is its own separate architecture. Each of these have slightly different options. So in general purpose, or if you're still using DTU, basic or standard, you're going to have compute and storage that are on separate nodes. And you're only going to have one active replica here for your compute, right? So the high availability is all at the storage level. So Azure Premium Storage, multiple copies of data and log files. If there is a problem with your primary replica, and this goes down, there's a spare node sitting here, but your database isn't pointed to it yet. So it goes, okay, we're going to spin this one up. We're going to attach the data and log files to the new node and start up the SQL Server process. So compared to the other options, such as business critical or hyperscale, this has slightly slower failover. Again, you're getting a new node, new SQL Server process. I would equate it to most closely running a failover cluster instance on premises, but that is not the technology underlying it here. Now, we want to contrast that with the business critical tier, or in DTU, the premium tier. So here you're going to have multiple nodes that have both your compute, your CPU and your memory, and locally attached SSD storage. So as you might have guessed, business critical is a little bit more expensive than general purpose. Not only do you get locally attached SSD, which means that the storage is faster, it also means you're going to have lower latency because the storage sits where the compute sits. For high availability, this is essentially, for all intents and purposes, a multi-node synchronous availability group running under the covers. You have one primary replica, and you're going to have at least 2 synchronous secondary replicas. If there is a failure event in your primary and this goes down, it will just fail over to one of your secondaries. Again, fully synchronous, faster failover, your data is already in sync. And let's go back. You have the ability to use these for read, scale out. Again, very similar to an availability group. Last but not least, the hyperscale service tier. So this is the newest hardware scale, the hardware offering or service tier offering with Azure SQL database. It's a scaled out architecture. I've been saying for a couple of years I'm going to build and give a presentation just on this, and someday I will. But they've broken the SQL Server process into 4 different sets of hardware. So your compute nodes run SQL Server and have your short-term data cache, like your buffer pool here. There's a separate compute that has the transaction log and the entire log writing cache and log writer service on it. So there's no IO contention between the two, no compute contention between the two. There's also a 3rd layer of page servers. So these hold, it's kind of like a warm cache for anything else in the buffer pool that's not immediately being read. And last but not least, there's this Azure storage layer at the bottom that holds your MDF and LDF files. All of these have redundancy built in. So your compute node is going to have, there'll be at least 1 high availability secondary. You can assign, I think it's up to 4 HA secondaries. So for page servers, every page server has an active pair. So if something were to go down with one of your page servers, it would just flip over to its pair. The transaction log service has Azure Premium Storage. So again, fully redundant with copies of storage and failover there. And your database files, again, also stored in Azure storage with redundancy, and then the database snapshots are taken there for backups. Hyperscale is cool. Hyperscale gives a lot of benefits. So again, there's a lot of different reasons to choose general purpose versus business critical versus hyperscale. And a lot of it comes down to, in the event of like your RTO and your RPO for the database, if you need it to be available again very quickly in the event of some sort of, again, catastrophic event or unplanned interruption, as that definition said, business critical and hyperscale are going to be faster. But again, that comes at the expense of having additional hardware, costing more, again, for testing databases, for things that have lower RTOs of, an hour or two, maybe general purpose is fine. So all of that needs to be taken into consideration, but know that all of these have high availability built in. Now with that, I'm going to refer back to this availability zones chat we had a little bit on backups. So by default, all of those compute nodes and your data storage are going to be provisioned in one data center in one region. But you can enable zone redundancy. And what that means is that compute and storage will be spread across 2 or more data centers in the same region. So this, again, it helps reduce that single point of failure if there is an outage. Say that electricity goes out to one data center. Your other one in the region is still available. This also, I've used this with customers in a couple of cases to, again, help achieve data residency laws. A company that wants their data to be in more than one data center, but again, the paired region is outside of their data boundaries. Enabling availability zones at least allows you to have multiple separate physical locations, more than one data center. And when we're looking at creating a database, again, in the portal, it's this: would you like to make this database zone redundant? Yes or no. Those that parameter also exists in the PowerShell commands to create a database, the CLI commands to create a database, and in the ARM template. And my last note about high availability and also disaster recovery for any data admins, any developers that work with databases, not just in Azure. This is a cloud-wide thing. Again, one of the benefits of using Azure SQL Database or Azure SQL Managed Instance is that this is a managed database. One of the things we manage for you are things like patching and maintenance. We'll upgrade underlying operating systems. We will upgrade the SQL bits. We will do patches. We do consistency checks. That requires databases to fail over to these secondaries. So these can and will be failed over. While you can set some maintenance windows, and we do have some options to allow you to get alerts about a rough time frame when it might happen, it's not like on premises where you get to control down to the minute when it starts and how long it takes. So, every application that connects to an Azure SQL database needs to have good retry logic built in. I've been saying that for years, and for years people are saying, "Oh, if only we could get the developers to listen." I understand, but I've been saying it for years. All right, so that's high availability for the different Azure SQL database tiers. Questions?
Yeah, I've had that same conversation with developers. I mean, it's they make it think like it's difficult to do that retry logic. I mean, it's as simple as just rerun your connection string, right? Like you retry to connect. I mean, like in Python, it was like 2 lines of code. In Java is maybe like 2 or 3 calls, and it's not that difficult. But yeah.
And there's a really great article somewhere out here in Docs on reliability. It might be this one. But yeah, designing for resiliency, dependencies, high availability using availability zones, best practices for reliability in applications.
Do you mind putting that link in the chat, Jess?
I don't mind at all.
Awesome.
Yeah. So this is like official Microsoft guidance on how to make these things work. I just have to find the chat. Here it is. Okay. So that can be helpful to pass on to people that you work with.
Great, thank you.
Yeah. All right, then our last pillar of business continuity, disaster recovery. So great thing is you can and maybe should configure this. Again, kind of like not every database on premises needs to be failed over to a secondary data center. Maybe not every database in Azure needs to be failed over to a secondary data center. There are some that are, again, development, testing, QA environments that if they're down for a couple hours, they're down for a couple hours. There are others that maybe, again, look at your RTO, look at your RPO. If it doesn't need to be recovered for 24 hours, like if that's your business agreement, then maybe you don't need to spend the money to have a secondary replica in another region. But when you do, we have two different options available for you. So the first is called active geo replication. This is like the OG. This existed first. So this is set up per SQL database. So if you want active geo replication, you do it one database at a time. You can create 1, 2, 3, or 4 secondary databases in another region. Number one, you are going to pay for every one of those. So if you have your primary and 2 secondaries, you are now paying for 1 primary and 2 secondaries, compute and storage. So keep that in mind. One of the benefits, though, of paying for that extra compute and storage in your secondary region is you can make these readable secondaries. So again, like an availability group where you have scale out, you can use those. Now, one thing to note about that is because this is per database, this is not by design behind any sort of load balancer or listener. So you either have to set up like an Azure load balancer and configure it yourself, or if there is some sort of failover, you have to go into the application and update the connection string to point to the new server. So just keep that in mind, a little bit more manual of a task. These are...
Sorry, could you not use like a DNS CNAME to move it from one connection to another? Just have a generic connection that points to one or the other?
Yes, if you, unlike me, are much smarter with Azure networking and would like to do that tangle yourself. But yeah, I'm just saying there's no like built-in listener like there is with availability groups. You have to configure something like outside of it. So again here, the replication from the primary to the secondaries will always be asynchronous. And here, another kind of drawback is the failover is manual. So active geo replication does not mean automatic geo replication, unfortunately. So what this looks like, again, you're going to have, and these are our official diagrams from documentation. You'll have a primary region, you'll have a secondary region. You have your server, you have your database, you have your secondary server, you have your second database, and the traffic is going to go through Azure's ingress, the app sends it to the primary. If there's if something happens here, right, you have to manually go in and say, fail over to this one. So again, very similar to like having an always on availability group, having a secondary, having it be manual failover. So how do we find this information? In the portal, right, you would go to your database, you would go to replicas, you can create a replica, you can view your existing replicas. I grabbed some screenshots in there, but it's much easier for me to just actually go to the portal and show you, because I want to show, first off, my CLI demo should be done now. Yes, okay, so here now I have 3 copies of the demo 3 database. So the one without the specific time appended is the one that came from CLI, and you can see that that did finish here in the terminal. So now say that I need to set one of these databases up with a failover replica. So I would come into the database itself, and here under data management, I would select replicas. So now when I say create replica, it is again going through another create SQL database wizard. Again, with some things filled in like what your primary database and region are. If it's a geo replica or a standby replica, this is new. I did not account for this in the last couple months since I gave this presentation. But this is good. This is 100% available now, so I definitely want to talk about this. Let's zoom in for a second. On premises with SQL Server, if you have your license, you have the ability to you have your license for your SQL Server. That licensing agreement says you can have one additional replica on another server that is your warm standby. It's not allowed to be used for production. It's not allowed to be used for queries, but you can have the database there. It can be your standby. And in the event of a problem with your primary, you can fail over to your secondary. That now becomes your primary. There's no additional licensing cost. So now that's never been available in Azure before, up until maybe a month or 2 ago. If you wanted this geo failover, you had, again, you were paying for your primary and each of your secondaries. A new feature is that you can now set up one standby replica. No, it cannot serve your read query, so it cannot be used as a readable. It does not incur additional licensing, but note you do still pay for the compute and storage cost, right? Because even if you had this on premises, you'd still be paying for storage, you'd still be paying for CPU. But okay, good. I'm glad to see that that's fully there now. Your other traditional option is called your geo replica, and that means that you can use that secondary for reads, for anything else that you want. So I'm going to put this on my DR server. Not going to use an elastic pool. I'm not going to change anything in terms of its configuration. I'm just going to say create. And there we go. So now we're building this geo-replicated copy of our database, same database, different region, different server.
So how does Microsoft keep track of how you're using something? You're saying you can't use it for X or Y. Is there like a process that they are running in the background and they'll say you tisk, tisk, you did something bad, pay the piper?
Microsoft follows the same process for standby replicas in Azure that it does for standby replicas on premises with full SQL Server licenses. And what that means is it's a trust relationship. we trust that our customers are following their licensing and agreements and are not using those secondary replicas for read workloads. To the best of my knowledge, again,
Okay.
best
Yeah,
of my
no,
knowledge, there's no like background processes that are going,
Right.
oh, which
Yeah,
app ran which query in which database. Yeah.
they could come and audit after,
Yeah.
means given that it's in their cloud, they could be more prone to auditing, or they're seeing some weird behavior.
Yeah.
Yeah.
But again, it's not some AI generated things in the background that are checking every query against every database.
Oh, I know Jes AI is already doing that. You're better than Chat GPT. Jes GPT is way better.
Jes GPT is way more fun and also could have accuracy ratings on it. I mean, you can ask me a question, I'll make up anything now. All right, so when is active geo-replication a good choice? It's great if your app has just one database, and that app can also benefit from one or more readable replicas. And again, that RTO is high enough to allow for the manual failover and either updates to the connection string, or you want to go through the trouble of setting up your load balancer or something with DNS. And okay, so now my deployment is complete here. So if I go to my resource now, I will see my demo 2023 614 SQL database, but this one is on my DR server, and that's in the West US 3 region. So I now have multiple different databases. Let me go to my resource group. SQL Server, SQL Server. Here. Yeah, so now if we go to my resource group, I'll see Jes Schultz and Jes Schultz DR, right? So one in South Central, one in West US. And then for my demo 3 2023 614, it even says, right, it links the two here in this list where it says this one is in West US 3. It's on the server. If I go to my original database now, so the original, no, that was the demo 3 614. Okay, so if I go to my database I created through CLI by restoring it, and I go to replicas, now it tells me my primary is on the Jes Schultz server in South Central US. My replica is on my DR server in West US. And this is where I can do things like stop the replication or force the failover to that other one. Those commands are, again, also available in CLI and in PowerShell. So that's all set up. All right, so then last but not least, failover groups. So failover groups are merely an abstraction of active geo-replication. The difference here is a failover group, as the name may imply, is a group of databases. So this is set up at the SQL server rather than the SQL database level. You can have one or more databases in the group. The other big differences here between the geo-replicated secondary and the failover group are, again, you have a load balancer and a listener baked right into this because there are multiple databases involved. That listener can be read-write for read scale out or read only. And you can set the failover to automatic. And again, because if it is automatic or even if it is manual, if you have that listener set up, your app doesn't need to be reconfigured to connect to this other secondary server. So again, terrible Azure diagram, just showing here the big difference being your ingress load balancer now sits at each, kind of outside of each region, allowing the Azure Traffic Manager to figure out which is primary and send it to the load balancer through the read-write listener or read-only listener. So this is a new piece. And again, the previous diagram had one database. This one has two. It could have multiple databases in the group. I actually don't know what the limit is for that. Now, again, this is something where you're going to access this through the SQL server rather than the database. So you'll have failover groups, and you'll be able to add a group or even manage existing groups. So let me give you a quick spin through that. All right, so this is at the database level that I have. So for my demo 2023 June 14th SQL database, I have a replica set up. But let's look at that Jes Schultz server. Again, this is one that has multiple databases on it. And let's look at, come on, scroll with me here, failover groups. There, my mouse was a little funky. All right, so I have two groups already, demo 2 and demo 4. But I think I've deleted all of the databases that were in those. Yep, databases within the group, none. Okay, so let's look at what adding a new group entails. Failover group demo. So when it says select a server here, this is the failover server, obviously not the one that we are already on. So I'm going to set up one again, a failover group between my primary and my DR. Again, I can say the failover is automatic or manual. In this case, it's going to be automatic. The read-write grace period, what that means, I think I had it here on a prior slide. Nope, I didn't. Okay, I thought I put that in there for documentation purposes, but essentially, if you have the read-write enabled and you want to make it essentially is a mechanism to ensure that even with automatic failover, it's not going to fail over immediately because it wants to give the secondary a chance to catch up to existing transactions. And I know I'm not explaining that well. Documentation is better than me in this one case. No. Now, what we need to do is just choose what database or databases are going to be in this group. In this case, maybe I want my wide world database and my demo database on there. I select, I create. And now what we're doing is building a bunch of things. It's making 2 more database copies, so this is going to take a minute. So while that's going, we'll come back to the slides. And again, failover groups are going to be better for applications that have multiple databases that need to fail over together and databases that have a lower RTO. And the failover has to be automatic. The time for it to come back has to be quicker. They don't have time to go in and do things like update a connection string manually. So that is my spiel on the DR options for Azure SQL Database, your active geo replicas and your failover groups. While that demo is finishing up, before I get to the last couple slides, any questions about that? Okay. All right, so we've learned a ton in the last hour. Just to kind of recap, again, the pillars of our business continuity plan with Azure SQL Database are going to be our backups, which Azure SQL DB takes automatically, stores in the primary region, and by default stores in a secondary region for you as well. Restores are simple. You, through the portal or PowerShell or CLI, simply provide the database name, the date and time you want to restore to, and it does the work of figuring out which backups go into that for you. High availability built into every tier of Azure SQL database. Just make sure that when choosing between general purpose, business critical, or hyperscale, you understand what the differences are there and match that up to what your resiliency requirements might be. And then last but not least, for disaster recovery, we have the active geo-replication for a single database or a failover for multiple databases on the same server. So we'll open it up for 5-ish minutes for questions. I have some resources here. Again, you can grab these slides off of my GitHub repo in my Azure presentations.
If you have a link, Jess, that would be great too.
Yep, going there right now.
Thank you.
GitHub.com. Oh, I live in the Microsoft repo a lot because I started typing that. Yes, so here is my GitHub repo with my presentations. Nope. Why does it only have one? Oh. All branches. Did I do something to this one? Ah, here we go. Sometimes I also put my presentation files in Azure SQL. I don't think I updated my repo quite right from VS Code because this should not just be hanging out here with its own little branch.
Oh,
But
I thought I'm the only one that's having an issue with connecting between my work and my personal GitHub and putting things on the wrong places. Like, yeah.
Nope.
Mhm. It's like they say branches is more like roots because you can't tell where it's going.
Isn't that the truth? All right. Well, if again, please reach out to me on Twitter, LinkedIn, email if you have questions. Otherwise, thanks for coming tonight.
Yeah.
This was fun. I love talking about this stuff. Happy to share my knowledge and hoping that maybe this year I might get to some more in-person conferences for those of you that are attending those. And if so, would be happy to meet and chat.
Awesome. Well, thank you, Jess. That was great. Very informative. And do you have your contact info page by any chance put up so folks can see? And
Oh yeah, let me get back there. Let me reshare my
Sure.
screen.
And anybody else?
Normally,
Oh yeah, go ahead.
I was going to say I normally put those at the end.
Just in case,
Just share. Yeah.
Somebody wants to send you some free bottles of bourbon.
Yeah. So my Twitter handle is girl_geek. LinkedIn, you can find me just Jes Schultz, and then again GitHub repo I put in there.
Cool. Anybody else have any question for Jess?
No, she did a fantastic job as always, and I'm sorry I slowed you down for questions.
No, I would never get through a presentation if I didn't get questions asked. So I enjoy the questions always.
Don't worry, we'll punish them later. All right.
Thanks. Thank you. Appreciate it.
All right. Well, thanks for everyone. I'm going to go indulge in my Whiskey Wednesday here on the East Coast. I hope you all have a fantastic rest of your day.
Yeah, you take care. Thank you. Good to see you again.
It was great to talk to you.
All right.
Bye.
Bye.